Hello. Here I'm going to graph y equals cosecant x minus pi over 6. Remember, this is the same thing as because cosecant is the inverse of sine. So some things we need to look at. The period is going to be 2 pi over b. Since your b here is 1, this implies that the period is equal to 2 pi. Then to find some asymptotes, let's set this denominator equal to 0. The denominator is 0 when sine of an angle is 0, and one such angle is 0. So we have 0 equals x minus pi over 6. This implies that x equals pi over 6 is an asymptote. So since pi over 6 is an asymptote, let's do these in just in case I get that far. So what I'm doing here, these are my pi. And when x is pi over 6, that's going to be an asymptote. So if this much is 1 pi, pi over 6 is going to be halfway in between here. And the period for sine, cosine, secant, and cosecant is 2 pi over b. So this period is going to, that's going to be an asymptote. That will be an asymptote. So that's when the period repeats itself. But half of these will be in the up portion, half will be in the lower portion. You'll see that then a little bit. So additional asymptotes will be right in the middle when you're dealing with secant and cosecant. So here we have an asymptote. You'll see when I complete the graph what I mean by this. So those are my asymptotes. Now, to graph this, I would recommend starting with, when you graph cosecant, I would recommend graphing sine. When you graph secant, I would recommend graphing cosine. Let me show you what I mean by that. So let's graph this. Okay. Now these zeros are going to be the same as your asymptotes. So we're going to have a 0 here, here, and you can plug these in to make sure. That's where the graph crosses the axes. Oh, sorry, that's where the graph crosses the horizontal axis. And to get a maximum, so let's put, since your A is 1, your amplitude is 1. So we know that sine of pi over 2 equals 1. So when does this equation equal pi over 2? Okay, so we set pi over 2 equals x minus pi over 6. We multiply everything by 6. We have 3 pi equals 6x minus pi. Add pi to both sides and we have 3 pi, sorry, 2 pi over 3. So if this is 1 pi over 3, this will be 2 pi over 3, and this is where we will have a maximum value. Similarly, at 5 pi over 3, we'll have a minimum. 8 pi over 3, 11 pi over 3. Okay. So that is the graph of y equals sine of x minus pi over 6. But we're graphing cosecant. Cosecant is the reciprocal of this. And so instead of it bowing down, let's make this go up. Let's make this go up. And you know how I was saying that the period is this much, but our asymptotes are half as much? That's because this one here, we also need to flip upside down. And then to make your graph look nice, we can eliminate that sine graph because the sine graph was just there to give us a framework. So that's 2 periods of the graph of y equals cosecant of x minus pi over 6. That is 2 periods. There's 1 period. There's your second one. Okay. Y equals 2 cosecant of x. Okay. So this is the same thing as y equals 2 divided by sine of x. The period is going to be 2 pi divided by b, so our period is going to be 2 pi. Our asymptotes are when the denominator is 0, so this is going to be at 0 and 1 pi and 2 pi and 3 pi. So let's make this pi over 2. No, that's and here our amplitude is 2. Then our asymptotes happen at 0. Also, sine of pi is 0. Sine of 2 pi is 0. So even though the period is 2 pi, for secant and cosecant, you will have twice as many amplitudes. How do I explain it? It's going to look like this. Okay. And then let's graph Let's graph y equals 2 sine of x. There is no phase shift, so we're going to start now when x is pi over 2, when x is pi over 2, sine of pi over 2 is 1. 1 times 2 is 2. That's why this point here will be on your graph. Our amplitude is 2 because of that. And I'll write it out here again. If we have, when x is pi over 2, we have this situation going on. So this is y is equal to 2 times whatever this is. Well, this happens to be 1. Therefore, this tells us that when x is pi over 2, y is 2. 2 times 1 is 2. When x is pi over 2, y is 2. So that point's on the graph. Similarly, there, these points are also going to be on the graph. Okay. And then connect the dots. I guess I could have spaced this out more. So this is y is equal to 2 sine of x. Our amplitude is 2. And then this pink is going to be the cosecant. So the pink, technically, that is 1 period. Right? You can graph as many as you like, unless your exam calls for a specific number of periods to be drawn. And then you're going to erase the evidence. Okay. So this is 3.5 periods, but all right. Okay. So this is the same thing as so the period is going to be 2 pi over b. So this period is going to be 1. When does the denominator equal 0? Well, that's when 2 pi x equals 0. This implies that x equals 0. So at x equals 0, we have an asymptote. And at 1/2 an asymptote, 1 asymptote, 3/2 asymptote. Let's deal with this period part first. And our A is 1, and this negative, careful with that. Our amplitude is 1/2. Put in our asymptotes. X equals 0 is an asymptote. This one has a period of 1, so there's an asymptote. And at all the halfway marks are asymptotes. Then we're going to kind of squint our eyes and graph the sine. So let's graph this. So regularly it would start here and go up and then down and then down. This is how the normal sine graph would look like. But since it's being negated, everything's going to be flipping. And so instead of the point up there, we're going to have a point down here. And instead of a point down here, we're going to have a point up here. And cosecant is the reciprocal of sine. And so all of these valleys do this, and all of the mountains, we can do this. And then we can erase the evidence of the sine graph since that's not exactly what we're graphing. The pink is the graph of y equals -1/2 cosecant 2 pi x. Thank you very much. Please go to tutoring.